Okay, guys, y'all be quiet. If I ask you to integrate 7x squared dx, first things first, what is my variable of integration? Dx. Okay, cool. Integrate this real fast for me. One person forgot the plus C. Well, one question was, what's the proper way of actually writing and showing your work? The best way to do this is just simply do 7 times x squared plus 1 over 2 plus 1 plus C. And then from there, we simplify and we get 7/3 x cubed plus C. You could have the x cubed up top with the 7, it doesn't matter.
Okay.
As long as it's not the denominator. Yes?
Okay.
Alright, so I want to do some more examples and then give y'all some to work. This is a lot of I do, y'all do.
Monkey see.
Yeah, pretty much. Monkey see, monkey do. Alright, so I want to do the integral of dx. I want to do the integral of x plus 2 dx. Then I'm going to do the integral of 3x to the 4th minus 5x squared plus x dx. And I'm going to show every step so you guys kind of get the feel for this. Alright, so what's an understood number between the integral sign and dx? 1. So what's the antiderivative of just a constant? Just x. So this just becomes x plus c and I'm done. That one's pretty straightforward. So what can we say generically? What if this was a 5? What would the antiderivative be? 5 what? 5x. What if this is n? nx. So whatever the constant is just your constant times x. Here, what's the derivative rule when you have things that are added together? Just do what? Just do both individually? Is it the sum rule? We can do the same thing here. We can do the sum or the integral of x dx plus the integral of 2 dx. I could pull this 2 out, but because it's so simple, it's basically this rule, I'm not going to. I'm just going to integrate it. This is x to 1 plus 1 over 1 plus 1 plus 2x plus c, ugly c. This gives me 1/2 x squared plus 2x plus c. Done. Questions on these so far? What's wrong, Vanessa?
We took part. There's only going to be one C.
Correct. Because a constant plus a constant is going to give you a constant. A constant plus a, so it doesn't matter how many times you do this. If I do a plus c plus and another plus c, like a c sub 1 plus c sub 2, two different constants, it's still going to be a constant. So I'm just going to write the c one time.
Okay.
Good question. All right. So over here, what rule am I going to use? I just said it. The sum rule. The last one I just said. Funny, Chandler. The sum rule, and also the starts with the D. The difference rule. Yeah, you're right. We're going to use the sum rule and the difference rule, which basically says we're just going to do each part by itself. right? So I'm going to do 3, pull my constant out, to the integral of x to the 4th dx minus 5 to the integral of x squared dx plus the integral of x dx. What's the integral of x to the 4th? X to the 4th plus 1 over 4 plus 1. Yeah? And then I'm just going to the next one. Minus 5 x squared plus 1 over 2 plus 1. Plus x1 plus 1 over 1 plus 1 plus c. Let's just clean it up. This gives me 3/5 x to the 5th minus 5/3 x cubed plus 1/2 x squared plus c. And I'm done. Terribly bad? No? Cool. I'm going to give y'all 3 to do. Y'all can rip through them. Y'all got these copied down? This is the last one. Guys, right now, get in the habit of just reinforcing this plus 1. Just get in the habit of reinforcing it. Are you good now, Vanessa?
Yes.
You good? All right. The integral of 4 dx. The integral of 2t minus 1 dt and the integral of x cubed minus 4x minus 2 dx. All right, guys, how long y'all think on this? 4 minutes? I heard that. Good point. All right, y'all agree 4x plus c. Timer, 4 minutes. Yes? Do y'all agree t squared minus t plus c? Yeah, I agree.
Okay,
Yeah. Do y'all agree 1/4 x to the 4th minus 2x squared minus 2x plus c? Yeah. All right, cool. Y'all got this integral stuff down, right? Yeah. Cool, I'm going to give you a harder one.
No way. I just got one. Shut up, nerd.
Wow.
Shut up, nerd.
Okay, boys and girls. Let's do this. Where's my sheet?
Should I just walk over and show everybody?
All right, here we go. I'm going to walk you through how to do the integral of x plus 1 over the square root of x dx. I'll walk you through that. Then I'm going to walk you through the integral of sine x over cosine squared x. No, let's just change that to theta. Theta d theta.
Did it take so much longer to write? You actually can just go // but then you have to go all the way back.
Oh my gosh, stop the whining.
Yeah, it's not right. I'm just
You can change it to x on your paper.
I'm stating the fact.
Theta, you don't have to pick your pencil up off the thing. Okay, boys and girls, now it's time to start being creative with the integrand. What is the integrand in this right here? What's the integrand?
Oh, it's a gram?
The first part.
This right here?
Everything, no, everything in the, everything that's like touching the thing.
Yeah.
The divisor, the dividing
That
line.
thing?
Yes.
Yeah.
The x plus 1 over the square root of x?
Yeah.
Well, then just say that.
Just say
that.
What's the integrand over here? Sine over cosine squared?
Yeah.
Right. Cool. But you're going to have to be creative because you don't know how to integrate this.
Why not? Just split them up.
However, we can split it up.
Oh, yeah.
We can split it up. What do you mean by splitting it up, Sean? You said split it up, and well, Sean said like my parents, but you said, come on.
Just do x plus 1 and then 1. That's good. And then you can do that.
Wait. You said do x plus 1
And then whatever something else, and you do 1 over 3.
1 over square root of x, like that?
Something like that.
Yeah, no. No.
You do it.
What's another way of splitting this up, guys? Use a noodle. A lot of y'all talking. What'd you say? Nope. I mean, I guess we could do it that way, but
EDU minus
you know what? Let's do it that way and see if we get the same answer as the way that I worked it on my paper. Anybody else have another idea? What did you say? Say it again. No, say it again. I didn't have to process it. Say it again.
X over square root of x and then 1 over square root.
Yeah, and then plus. That's what I do. Which is going to end up being the same thing you do, because when you do x to the negative 1 and distribute, you're going to get the same thing. Right? So what I did is x over the square root of x dx plus 1 over the square root of x dx. I split it up like that, and then I did my exponents for my paper. Make sure that's the way I went. I didn't do anything crazy. I have a tendency to do crazy stuff. Yeah, and then from here, if you were to just change to the negative 1, you would have distributed and got there. But here, change it to the integral of x times x to the negative 1/2 dx, and then the integral of x to the negative 1/2 dx. What is this? This is what? X to what power? 1/2 power. You add, same bases, you add your exponents. So it's 1 plus a negative 1/2. So x to the 1/2 dx plus, what is the integral of this? X to the negative 1/2 plus 1 over a negative 1/2 plus 1. Yeah? I'm going to go ahead and put my plus c on there. And then this, so the whole thing will end up being x to the 1/2 plus 1 over 1/2 plus 1 plus x, let's see, negative 1/2 plus 1 is 1/2 over 1/2, yes? So this is x to the, what is that, 3/2?
Yeah.
Over 3/2 plus 2 x to the 1/2, right?
Yeah.
Then this becomes 2 x to the 3/2 over 3 plus 2 x to the 1/2 plus c plus c plus c. Voila, you're done. And you're done from there. Just need to make sure I have the right answer. I hate to put this on the internet with the wrong answer. Alright, so next one. What are we going to do with this one, you think? Split it up. We need to rewrite the integrand into something that's nice and easy and integratable. Now, when I say integratable, Amanda, what do you think I mean by that? Integratable. What about differentiable? If something's differentiable, what does that mean? Hold up. Stop with the drumming. So it's integratable. Good. Not the derivative, but the integratable. Take the integral. Take the integral of it. Alright. So, we can't really take the integral of sine over cosine squared. We can, though, take the integral of, I'm going to give Amanda this, because I feel like giving it to you. Tell me what sheet number 32. Alright guys, y'all listen up. You want me to just write it on the board? Alright guys. There are integratable, there's tables of integration. So what this means is you actually have a table of a bunch of integrals. Okay? What I'm going to do is I'm actually going to print this one out for you. I just got to go pull it up and print it out for you. It's got a whole bunch of stuff in here that you won't need, but it'll have everything that you do need. Does that make sense?
Yes.
Okay. So there is one integral that I'm eyeing. Where is it? I just had it. I said 32, right?
I was left.
Yep. Alright, here's one that I'm eyeing. The integral of secant to the power of n ax tangent ax dx equals 1 over na secant to the n ax plus c. Y'all are like, what? Why did I pick that one? Because see cosine squared. What's 1 over cosine? 1 over cosine tangent? It's secant. And that's going to leave me sine over cosine. What's sine over cosine? So you're telling me that this is actually secant tangent? It is. So I could break it up. I could do sine theta over cosine theta times 1 over cosine theta d theta, which now gives me the integral of, let's just put it in the order, secant theta tangent theta d theta. Voila. Now it's starting to look like this, right? What's my A in secant and tangent? 1. Have to be the same number because it's A and an A. What's my N on secant?
1.
So what does this integrate to? 1 over 1 times 1, which is 1. Secant to the N, what was my N? 1. So secant, my A was 1. So this just becomes secant theta plus C. I'm not going through the proof. In your book at home, it's going to have a QR code with the proof on it. So secant theta plus C, and you're done. Was that terribly bad?
So the tangent disappears?
Huh?
Rather than tangent.
I can't hear you.
Rather than tangent.
There is a proof to explain this in your book at home. If you really want to know, you can go look it up. I don't know what page it is. I know what's in there.
It's in it somewhere.
I'm busting my balls on that.
What's your balls or balls?
Okay.
You know what he said.
So you're going to have, so here's the moral to the story on this. Y'all ready? You have to think outside the box. You have to think outside the box. If you don't think outside the box, you may never figure some of these out. You're going to have to think outside of the box. This is what makes integration difficult. We're doing baby integration. But this is what makes integration difficult, because as it gets more and more complex, you have to start thinking, how can I rearrange things to make it work? All right, everybody got this copy down? I'm going to give y'all two to try. I will give you the integrals from the tables that I think you need.
I think I tried the back.
Oh, what is wrong with my board? It's like it's got a bunch of sticky stuff on it. Sean, what are you doing to my board? All right. I want you to integrate sine theta plus 1 over cosine squared theta, d theta. What I think you're going to need is the one that, did y'all write that one down over here?
Yeah.
Everybody wrote that down? No. How dare you not write down what I put on the board?
Wait, like the far right one?
Yes.
Oh, he took out the book? That one?
So what I think you're going to need, I'm going to put a star by it. The integral of, I'm just going to be generic, secant, no, I'm not going to be generic, N-A-X, tangent, A-X, dx equals 1 over N-A secant N x plus c. I also think you're going to need the integral of secant squared ax dx equals 1 over a tangent ax plus c. I think you're going to need those two integrals on that one. And then, where did my paper go? I want y'all to do this one. The integral of x minus 2 over 2x squared. Integrate that also for me. This one's going to take a little bit more time. Y'all think like 7 minutes? 7 minutes?
Yeah, about 7 minutes.
Timer, 7 minutes. Guys, let's talk and we're working. Oh my goodness, Jonathan's actually putting paper to pencil.
I expect better.
Figured that.
You never know.
You just want to point those down?
Yeah, how do you do from there?
You don't know what to do from there?
Yeah, that doesn't make sense. I don't have a rifle.
Use your brain power. Talk to each other. Look at your notes.
That's what I was doing.
I'll do the second one. Yeah, but nobody was like,
Yeah, you said less talking, more working. Nice you can talk to. That's crazy.
That's fair. That's a fair one. Sean?
I think that's
LaShawn?
yeah, that's like, bro.
The answer to this is about the problem. Secant theta plus tangent theta plus c.
Does it matter if we split them?
What do you mean split them?
Not split them, like tangent theta.
Yeah, well, it doesn't. The commutative property, it doesn't matter.
How many did I get here?
And then this one over here is going to be 1/2 ln of the absolute value of x plus 1 over x plus c. So this way you can continue working on these at home and you have the answers. Not of these, but
That's what the other I did not have to read the other this one. I was like, how am I supposed to apply these now?
alright guys, good job today.
Yeah. I'm not gonna say